All right, we are gonna do 3.1. We're gonna do the exercises. Okay. Alternate way to represent a positive number is as a successor of some nat. All right, let's try this. Um, oh yeah, I never finished that part. All right, let us call it. Let me call it pause. I don't want to rewrite all the other POS. The first version that's in the example. I guess we have to add an instance. All right. All right. So instance add costs where. Oh, okay. It should be instant plus. Okay. Get confused by the syntax. Okay. Now we need a plus. So we need a plus AB, and we can just say red. So it's saying red is a nat. Do I understand this? Okay, so suck is the constructor, and then pred is okay. So I'm not sure I understand this. But let's try to do it anyway. Okay, so def pause plus is pause to pause to pause. Okay, and then we just need um so I guess we just have one instance. Is that right? It's just a structure. It's not. It's a structure. It's not an inductive type anymore. It's not a sum type. So can I just pattern match on this? Like, I don't think this is going to work. Function expected. Yeah, well, we have to first write plus, but I'm not. Okay, okay, let's start simpler here. Let's just say define. Actually, let's just do check suck. Okay, I think this is gonna be suck is a constructor, so it's gonna be a nat to a pos. What? Okay, that is correct. Let's call this pos. There we go. Now we're cool. And then pred is a destructor. Yes, it is. Okay, we have nat to pos and pos to nat. Okay, so now okay, so then how do I pattern match here? You know, it's like that's how I would do it in Haskell. And then we would destruct this. We'd say A dot pred and B dot pred. Actually, can I just. What do you mean function expected? Why is this not. Is that what I need? Okay, now how do I introduce these terms like pattern match against this one and this one? Should we cheat? Okay, so I still need the bar. And I don't need this. And one of these. Okay, so now, yeah. So, okay, we could say A. That doesn't work, really? Okay, no, we need a comma. Dear God. Okay, now we need a. Okay, so now we can do A dot pred plus B dot pred, but make it into a pos. We need a B, bring back the B. Oh my gosh, that was painful. All right. I think that's okay. So now we can do an instance. Okay, no, instance add pos where, okay, and then we have to do add equals, right? Let's do it with points. Get points for your points. Actually, you lose points for your points. So that's okay. We could, and we good. We good. Okay, now no points. If you know, you know. All right. So now let's say 1z is a pos, and that equals Suck 0. What? There we go. Okay, and then we need a 2s. And that's going to equal a... Okay, no, we can't do that. We have to do... We could just do the literal, right? Yeah, we could also do the literal here. Okay, and now if we do 3s, this should be a pause, but now we got to move it into the right spot, and then we'll say no, really? Oh, plus. Just equals 1, huh? That's... I thought it would be this... I thought that would be a 2 that we were looking at right there. Okay, so... All right, this is confusing as possible. Like, this is just off by 1 errors by design. Okay, but we could definitely say this is correct. This is wrong. Why is this wrong? Shouldn't I just be able to use natural numbers here to add? I mean, add 0. Well, no, actually, I guess this is right. 0. How is this right? I mean, this is... Oh, the predecessor. Oh, there should be no 0. It's the successor. Dude, I'm so confused. Saying 1 plus 2 equals 2. That's not right. Do we need to... Oh, we might need to take a suck in here. Okay, now we're okay. Now we're okay. Right? Okay, so now this, we're going to put in 3s plus 3s. And that's 6, so we should see a 5. Oh, what's up? All right. Welcome to Lean Torture.